In this session we shall see the stepwise procedure to design road tunnels. Step 1. Open main screen of Heads Pro. By double-clicking on the desktop icon, select Menu Item File. Select Working Folder. Step 2. The folder is selected as exists, or user ma browse and create and select folder Work6 as the working folder. Click on OK. The project folder will be created inside the working folder. Step 3. Select Menu Item, File New/Open Project Workspace Tunnel Design Suite New/Open Tunnel Design. Step 4. The project workspace opens for Tunnel Design. Click on button Create Project. The project folder will be created as Design Job Number 01 inside User's Working Folder. Step 5. Message comes confirming that the project folder will be created. Click on OK. Step 6. There are two browse buttons. Click on the upper button to select the total station survey data file containing topo survey data take on the ground surface. Step 7. Select the total station survey data file from any location in the PC/laptop. Click on button Open. Step 8. A copy of the survey data file is taken inside the project folder Work6 Tunnel Design Project Design Job Number 01 Tunnel Design for processing the data. Message comes. Click on OK. The total station topo survey data file ground.txt is opened in Notepad. This file contains ground elevation data at various CO ordinates on the upper ground surface. After viewing, close the Notepad. Step 9. Click on the lower Browse button, to select the tunnel survey data taken by robot total station in Trimble format. This data is automatically scanned inside the tunnel for as-built condition. Step 10. Select the file tunnel survey data.txt from any location of the PC/laptop. Click on button Open. Step 11. A copy of the survey data file is taken inside the project folder Work6 Tunnel Design Project Design Job Number 01 Tunnel Design for processing the data. Message comes. Click on OK. The robot total station scan as built survey data file tunnel survey data.txt is opened in Notepad. This file contains ground elevation data at various CO ordinates inside the excavated or bored tunnel. After viewing, close the Notepad. Step 12. Open tab window Process survey data. There are three more tabs under this tab. The first tab is opened as Step 1, Ground Model. Click on button Create Ground Model. This will process total station survey data taken on the ground surface. Step 13. As the process is over, the message comes. Click on OK. Step 14. In the list the survey feature comes as OGL, Original Ground Level. Click on the box in column color for feature OGL. Step 15. Select a desired color. Click on button Apply. Step 16. Click on button Draw at the bottom of the left side window. Step 17. The ground model is drawn for the selected feature OGL. Step 18. Open tab page. Step 2. Triangulation. It is under the primary tab Process survey data. Click on button Create Triangulation Model. Step 19. The process dialog box come. Click on button Proceed. Step 20. As the process is over, the message comes mentioning about the output. Click on OK. Step 21. Open tab page. Step 3. Contour. It is under primary tab Process survey data. By default the primary contour interval is shown as 1.0 m. The secondary contour interval is always 5 times of the primary interval. In case of a flat ground, the primary contour interval may be given as 0.1 m and the secondary interval will be 0.5 m. The contour elevations will be written on secondary contours. Click on button Create Contour Model. Step 22. The process dialog box comes. Click on button Run. Step 23. The contour window opens and shows the process of creating contours on the triangulation model. As the process is over, click on the button Save on top panel of the contour window. Step 24. Next, click on yellow color contour icon at the bottom panel of the contour window. As the dialog box comes, click on the button Quit to close the contour window. Step 25. Next, we come back to the tab for contour in the project workspace. Click on button Draw Contour Model. Step 26. Contours are being drawn and wait for some time. The contour model is drawn over the ground model. Step 27. Open tab page Tunnel Design. Under this tab page there are more tabs for various tasks of the design process. Currently the tab Step 4, Horizontal Alignment is open. Select option Process Halon Design Data from the drop-down list as shown. Step 28. Copy Halon design data from its source, normally halonment.rep, where any previous design is done, and paste the Halon design data in the box at the left side of the workspace. By clicking on the button Proceed, the Halon design data will be processed. Step 29, alternatively, where there is no previous Halon design data, select option New Halon Design from the drop-down list as shown, click on button Proceed. Step 30, the Heads viewer opens with CAD features for interactive design of the horizontal alignment of the tunnel. Select item polyline from menu Draw and click the points by following the turns and bends of the ground model. Please note that the points must not be clicked very close to each other, this will result overlapping of curves which are to be assigned at these points. These points are horizontal intersection points, HIP. Click right mouse button to terminate the polyline. Step 31, select menu item Design Alignment New HIP method. Step 32, click the left and then right mouse buttons on the polyline. Step 33, the design dialog box comes, user may change the data as desired, click on button Apply. Step 34, message comes saying that the curve is large at a HIP, reduce the curve radius. Necessary lead and trail transition curves may be entered as per the design standard, and click on button Apply. If no message comes for large curve then click on button Save and Finish. Step 35, next comes the dialog box for modeling the design, select the string M001, click on OK. Step 36, the modeling process dialog box comes, click on button Proceed. Step 37, as the modeling process is over, the message comes, click on OK, close the design window Heads viewer. Step 38, now we are once again back to the tab page for step 4 in the design workspace, click on button View Halon Design. Step 39, the designed horizontal alignment is being drawn, please wait. Step 40, the alignment with tangents and curves is drawn, this is just for viewing only. Step 41, click on button Change on, the dialog box comes, select the string M001 and enter other details, click on OK. Step 42, the changes are displayed along the alignment of the road center line, next, click on button Details on. Step 43, the dialog box comes, select the string M001 and enter other details, click on OK. Step 44, the curve details are displayed at the hips along the alignment of the road center line. Step 45, open the next tab. Step 5, vertical profile, click on button Create ground long section. Step 46, the process dialog box comes, click on button Proceed. Step 47, the message comes to start the process, click on OK. Step 48, as the process is over the string E001 for the ground long section along the road center line is stored in the model files and the message comes, click on OK. Step 49, click on the button Draw ground long section. Step 50, the dialog box comes, the default horizontal and vertical scales are mentioned, click on OK. Step 51, the ground long section is drawn describing the ground elevations at the surface level, click on button Create as built long section. Step 52, as the process dialog box comes, click on button Proceed. Step 53, as the process finishes the message comes mentioning about the output, click on OK. Step 54, click on the button Draw as built long section, the dialog box comes, the default horizontal and vertical scales are mentioned, click on OK. Step 55, the as built long section is drawn, next, user may either select the option Process via line design data if any previous design is available, paste the via line data in the lower left box. Step 56, click on button Proceed, the via line data will be processed. Step 57, alternatively, user may select the option New via line design if no previous design is available, and click on button Proceed. Step 58, the Heads viewer opens as the design window, select menu items as Design ground long section Draw vertical profile. Step 59, the dialog box comes, select the model as built, select the string TBCL which is tunnel bottom center line. Step 60, the scales are mentioned, click on OK. Step 61, the as built long section is displayed, click on icon on the right side of the window as for drawing a polyline, and click on a number of points on the ground long section to draw a polyline. To finish the polyline click the right mouse button. The polyline should pass as close as possible to the ground long section, the points should be sufficiently away from each other to accommodate curves to be set at these points. These points are called vertical intersection points, VIP. Step 62, select the menu items as Design via Alignment New VIP DSN. Step 63, click the left and right mouse buttons on the polyline. Step 64, the design dialog box comes. User may change the data as desired. Click on button Apply. Step 65, if any message comes for large curve, the vertical curve length, VCL, is to be reduced, and again click on Apply. If no message comes, then click on button Save and Finish. Step 66, next comes the dialog box for modeling the design. Select the string M001, click on OK. Step 67, as the process dialog box comes, click on Proceed. Step 68, as the process is over, the message comes, click on OK, close the design window heads viewer. Step 69, now we are back to the window for step 5 in the design workspace, click on button Draw Vertical Profile. Step 70, the dialog box comes, select the string M001 and click on OK. Step 71, the designed vertical profile for the center line of the road is drawn. Step 72, the V-align design data is displayed on the left side box, click on button Grid On. Step 73, the dialog box comes, the default parameters are mentioned and click on OK. Step 74, the grids are displayed with 1:10 scale over the designed vertical profile of the road center line, shenaches are displayed at the bottom and elevations are displayed at the left vertical side, click on button Vertical Details On. Step 75, the dialog box comes, select the string M001, click on button OK. Step 76, the design vertical details are displayed along the vertical profile of the road center line. Step 77, next, the tab window Step 6 and 7 cross section is opened, inside there are 3 more tabs. Currently the tab Define Road Cross Sections is opened, and under this tab Step 6 is opened. For selecting the typical cross section, TCS, there are 2 TCS available, as this is a uniform cross-section highway, so from start to end the cross-section is considered as same and a particular TCS is to be applied throughout the alignment of the road. User may click on a TCS and may see the particular TCS. Step 78, here we select the TCS01, click on button Save Schedule Data. Step 79, the message comes mentioning that the selected cross-section is saved, and next the dimensions for various cross-section elements is to be entered. Step 80, open tab Step 7, inside there are 2 more tabs. Currently the tab Define Cross Section is opened, the various default data are mentioned. User may change the data in authorized version, click on button Save Data. Step 81, the message comes, click on OK. Step 82, now under the tab Step 7 open the tab Create Cross Section, click on button Process Cross Section Data. Step 83, the process window comes with various design actions. Each one is to be processed one after another, click on button Proceed. Step 84, the first process starts to create 3 strings CL01, CL02, CL03 on the left side and string CR01, CR02, CR03 on the right side forming the dummy central median, click on button Proceed. Step 85, as the process is over the message comes, click on OK. Step 86, the next process will create the super elevated left carriageway edge as string CL04 in the model files, click on button Proceed. Step 87, as the process is over the message comes, click on OK and Finish. Step 88, the next process will create the super elevated right carriageway edge as string CR04 in the model files, click on button Proceed. Step 89, as the process is over the message comes, click on OK and Finish. Step 90, the next process will create the super elevated left paved shoulder edge as string CL05 in the model files, click on button Proceed. Step 91, as the process is over the message comes, click on OK and Finish. Step 92, the next process will create the super elevated right paved shoulder edge as string CR05 in the model files, click on button Proceed. Step 93, as the process is over the message comes, click on OK and Finish. Step 94, the next process will create the left and right edges of the earthen shoulders as strings CL06 and CR06 respectively in the model files, click on button Proceed. Step 95, as the process is over the message comes, click on OK. Step 96, the next process will create offset strings as CL07 and CR07 to make CL06 and CR06 as continuous strings and to store in the model files, click on button Proceed. Step 97, as the process is over the message comes, click on OK. Step 98, the next process will create the cross section of the road top formation, by uniting all the Strings from CL01 through CL07 on the left side of the center line and strings from CR01 through CR07 on the right side of the center line, in actual sequence of their occurrences in the cross-section. Step 99, the message comes as shown, click on OK. Step 100, the next message comes as shown, click on OK. Step 101, as the process is over, the cross-sections are created in text file hds002.fill, the message comes as shown, click on OK. Step 102, as all the 9 processes are over, click on button Finish. Step 103, the dialog box comes with list of all strings, click on button Draw Strings. Step 104, the strings are being drawn, please wait. Step 105, the strings are drawn, click on button Create Cross-Section Drawings on the left side of the window. Step 106, the cross-sections are displayed, these are for viewing only. Step 107, select any shenage to view the cross-section and the cross-section at that particular shenage will be displayed. Step 108, user has to check the cross-section with the plan view as displayed on the right side of the window. Step 109, open the tab page Define Tunnel Cross-Sections, from the drop-down list select item Custom as shown below. Step 110, the message comes, click on OK. Step 111, wait for the Excel file to open. Step 112, as the Excel file opens, the current page is Tunnel Custom Cross-Section 3 lanes. In case any change in cross-section is required, user can do that, select Save As, select other formats as shown. Step 113, select the location as shown to save the file, save type as text, tab delimited, click on button Save, the file is saved as a text file which will be used for next process. Step 114, close the Excel file. Step 115, open the tab page Create Cross-Sections, click on button Process Cross-Section Data. Step 116, the batch processing window comes with 2 processes in proper sequence, click on button Proceed as shown. Step 117, the first process starts, the process dialog box comes, click on button Proceed. Step 118, as the process is over the message comes informing about the output generated, click on OK. Step 119, the next process starts and the process dialog box comes, again click on the button Proceed. Step 120, a message comes, click on OK. Step 121, the next message comes, again click on OK. Step 122, as the process is over the message comes, click on OK. Step 123, as the 2 processes are over, click on the button Finish as shown. Step 124, the list box comes with all the strings to be drawn, click on button Draw Strings. Step 125, the strings are being drawn, please wait. Step 126, the strings are drawn in 3D, click on button Create Tunnel Cross-Sections. Step 127, the selection box comes, select the option Cross-Sections of Tunnel with Road, click on OK. Step 128, the next dialog box comes, click on button Proceed and wait for a while. Step 129, the cross-section window appears shown as Build Cut with Design Cross-Section, user can go forward and backward by using the buttons and respectively. Step 130, user can select a shenage to see the cross-section at that shenage. Step 131, next, user has to close the cross-section window. Step 132, coming back to the project workspace, the dialog box appears, click on button Finish. Step 133, in the project workspace also user can see the cross-sections of as built against the design cross-section. Step 134, by selecting a particular shenage here also user can see the tunnel cross-section at that particular shenage. Step 135, the cross-section and the tunnel in plan are displayed side by side. Step 136, open the tab page Step 8 Drawings, under this tab page there are 3 more tab pages Plan, Profile and Cross-Sections, currently the tab page Plan is open, the default data are mentioned, accepting the same data click on button Process Data. Step 137, the Process dialog box comes, click on button Proceed. Step 138, as the process finishes the message comes informing about the output, click on OK. Step 139, next, open the tab page profile is open, the default data are mentioned, accepting the same data click on button process data. Step 140, the process starts and the dialog box comes, click on button proceed. Step 141, as the process is over the message comes informing about the output, click on OK. Step 142, next, open the tab page cross section is open, the default data are mentioned, accepting the same data click on button process data. Step 143, the cross sections are already created in the project folder, the message comes informing about the output, click on OK. Step 144, open tab page. Step 9, design details, there are 8 buttons in this tab page, click on button create/update project data file. Step 145, the project data is opened in the window and the message comes, click on OK. Step 146, next, click on button view project data file, the project data file opens in Notepad, after watching close the Notepad. Step 147, next, click on button open ground total station survey data, the ground total station survey data in file ground.txt opens in Notepad, after watching close the Notepad. Step 148, next, click on button open tunnel robot total station survey data, the tunnel scanned is built by robot total station survey data in Trimble format in file tunnel survey data.txt opens in Notepad, after watching close the Notepad. Step 149, next, click on button view report files. Step 150, the report list is displayed on the left side, by selecting a report that is displayed on the right side. Step 151, next, click on button view drawings. Step 152, the message comes, click on button yes. Step 153, the heads CAD viewer opens with list of all drawings, select a drawing in the list and the drawing will be displayed. After viewing all the drawings close the heads viewer. Step 154, next, click on button tunnel custom cross sections TCS drawings. Step 155, the drawings are opened with a list. Step 156, by selecting a drawing in the list the drawing can be viewed. Step 157, click on the button open viewer. Step 158, the heads CAD viewer opens, user can select and open any drawing from the project folder. Step 159, select the tab page coach profile, under it tab page horizontal alignment is currently open, select the option process Halin design data, paste the Halin data by copying from the report file halinment.rep as designed before, click on button proceed, the process dialog box comes, click on button proceed. Step 160, as the process is over, the message comes informing about the output, click on OK. Step 161, click on button view Halin design. Step 162, the horizontal alignment with tangents and curves is drawn, this is just for viewing only. Step 163, click on button Shenage on, the dialog box comes, select the string M001 and enter other details, click on OK. Step 164, the Shenages are displayed along the alignment of the road/tunnel center line, next, click on button details on. Step 165, the dialog box comes, select the string M001 and enter other details, click on OK. Step 166, the curve details are displayed along the alignment of the road/tunnel center line. Step 167, in the tab page coach profile, open the tab page vertical profile, select the option process via-line design data, paste the via-line data by copying from the report file viaalignment.rep as designed before, click on button proceed. Step 168, the process dialog box comes, click on button proceed. Step 169, as the process is over the message comes, click on OK. Step 170, click on button draw vertical profile. Step 171, the dialog box comes with scales, click on OK. Step 172, the designed vertical profile for the center line of the road is drawn, the via-line design data is displayed on the left side box, click on button grid on. Step 173, the grids are displayed with 110 scale over the designed vertical profile of the road center line, Shenages are displayed at the bottom and elevations are displayed at the left vertical side. Step 174, Click on button vertical details on, the dialog box comes, select the string M001, click on button OK. Step 175, the design vertical details are displayed along the vertical profile of the tunnel center line. Step 176, open the tab page coach profile inputs, various data are displayed and can be changed. Step 177, open the tab page process data, click on button process coach profile data. Step 178, the batch process window comes with 4 processes in proper sequence, click on button proceed. Step 179, as the process starts create the strings in the cross section, the dialog box comes, click on button proceed. Step 180, as the process finishes the message comes, click on OK. Step 181, the next process starts to create super elevation, or cant in rail tracks, and the dialog box comes, click on button proceed. Step 182, as the process finishes the message comes, click on OK. Step 183, the next process starts for creating the cross-section models and the dialog box comes, click on button proceed. Step 184, the first message comes, click on OK. Step 185, the second message comes next, click on OK. Step 186, as the process finishes the message comes, click on OK. Step 187, the next process starts and the dialog box comes to create the drawings, click on button proceed. Step 188, as the process finishes the message comes, click on OK. Step 189, as all the processes are over, click on button finish as shown. Step 190, now the window in tab page process data, has the cross sections in display. Step 191, by selecting a shenage we can see the cross section at the particular shenage. Step 192, open the tab page design details, there are 5 buttons in this tab page, click on the button create/update project data file. Step 193, the project data file is created and the message comes, click on OK. Step 194, click on the button view project data file, the project data file is displayed on the screen and is also opened in Notepad to take printouts. This is the backup file of the design data and may be processed along with the total station survey data file by taking these files in a new folder. Step 195, click on the button View Report Files. Step 196, the window opens with a list of report files on the left side, select a report and the report file is displayed to view or to take printouts. Step 197, click on the button View Drawings. Step 198, the message box comes, click on button Yes. Step 199, the Heads CAD viewer opens with a list of various drawings created inside a folder Design Drawings. Inside the project folder that was created at the start of this session under the working folder select by the user, select a drawing in the list and the drawing is displayed to save or print. After viewing the drawings close the CAD viewer without saving the drawings. In unauthorized version of Heads Pro the drawings cannot be saved or printed. Step 200, by clicking on the button Open Viewer user can open the Heads CAD viewer. Step 201, we are again back to the tab page of the project workspace, close the project workspace, the message comes asking whether to save/update the project data file, click on button Yes. Step 202, the message, click on OK. Step 203, again the message, click on OK. This is the end of the session for design of tunnels.